All right, so in this lesson we're going to be talking about interpreting graphs, more to the point of determining where a graph's increasing, where it's decreasing, and where it's staying constant. So some pretty simple things. We're going to be looking at qualitative graphs, and so you should have already defined in your notes that a qualitative graph is an expression or expresses the important characteristics of a situation that does not necessarily have numerical values in a visual form. So, for instance, this graph here, that could go for a situation like a skier. It goes up a mountain. I'm going to abbreviate mountain. At a steady pace. And then skis downhill. So I know when we visualize a skier going up the mountain and then going downhill, we're thinking more up the mountain and then downhill, but that's distance, right? And that's if we're talking about like distance from the base or something. But when we look at our graph here, we're thinking of speed over time. And so it tells us that we have a steady pace. Well, that steady pace is going to be this constant. It's the same pace the whole time. It's not changing. So if you have a flat line, we call that a constant. And then when you think about, well, anytime you go downhill, right, whether that's skiing, whether that's driving and you're just coasting, your speed increases. And so that's what this line going up shows, is that the skier's speed, how fast the skier's going down the hill, increases as they go down the hill. And so we have now taken a situation of which we have no numbers. We just know that it's a steady pace and then they increase, and we've created a graph. And so that's what we call a qualitative graph. So when interpreting a graph, just keep in mind that many situations can be interpreted from a graph. That last one was speed over time. This one, we're talking about temperature, right? And so as the day progresses, our temperature increases. We get to the top, right? This would normally be what meteorologists call the high of the day, right? And then we see a decrease. And we could get more specific about a gradual decrease, and then it leveled off for a little bit, and then a very steep decrease. But in essence, we increased, we hit our high temperature for that day, and then we started decreasing as the day went on. And so again, that's just interpreting the graph, just by using increase, constant, and decrease. So let's look at example 1. We're going to label each of these intervals as increasing, constant, or decreasing. So we're going to start with interval A. That's this one right here. Now, because we should always read from left to right, just like you read in English class. So from left to right, our line is going down. So that's going to signify a decrease. And then when we look at B, from left to right, it's staying flat. And because it's flat, that's going to be a constant interval, because it is staying that constant, and we're working with speed, that constant speed. C, from left to right, rises, it goes up. And so C is going to be an increasing interval, so it increases. And then D again flattens out, and so that's a constant. That would be like speeding up to get to 40 miles an hour, and then turning on your cruise control and letting your cruise control go. But that's basically what you're doing in your homework, saying whether an interval is increasing, decreasing, or constant. So example 2, label the graph to indicate which intervals are increasing, decreasing, or constant. So on this one, again, reading from left to right, I know that the arrows are pointing down on both, but I've got to start from the left and go to the right. And when I do that, I'm actually drawing up the graph. So on the left, we are increasing. And then we get here, and that's when we start to go down. And so on the right, we are decreasing. And it's really as simple. There is no constant in this case because there's no spot where we're going at a constant rate for a while. All right, the graph shows the speed of a commuter boat as it makes its evening trip. And we want to know how many different intervals, constant intervals, are defined on the graph. And so we look at the graph and we're looking for those flat spots. So here's a flat. There's 3 easy ones to spot, right? And then you have your 2 that are hidden at the bottom. So there's a total of 5 constant intervals. Then it says, well, how are the constant intervals alike? Well, you could talk about how 2 of them are at the same speed. If they were all for the same amount of time, then you could talk about that. The 2 at the same speed are actually also for the same amount of time, but they all indicate when the speed is constant. So when it's not changing, it's at a steady pace, whether that's the boat putting it on cruise and letting it just go, but there's that steady pace. How are the constant intervals different? And so we can talk about how they have different time lengths. So we have different time lengths. So, for how long they were cruising along and staying that constant speed. We also have different speeds, right? Except for the 2 at the bottom, all the rest are happening at a different speed. And so this is similar to a question you'll be asked on your homework. The next video we're going to talk about sketching graphs. And so I'll see you over there.